All right, so we've got bell work up here. First one, we've seen some like it before, but it's been a minute. And it's gonna come up Friday when we finally use it. So why the heck we care about this thing? So if I just ask you to evaluate that, what do we do for this first part? Substitute it in. I know what A is, I know what B is, I know what C is. Substitute them in. Be careful because we've got some negative numbers in there. But what are we substituting in? So we know that our B is going to be -9, so we need that to be our -9 squared. That's our B. Where's this guy? Then we have our ooh, that's not a pen. -4 times our A, which is a -4. So again, we're going to put it in parentheses, -4. Times our C, which is 5. So like this. When we substitute them in, I do recommend putting them in parentheses. It really does make a difference, especially when we're looking at that -9 in parentheses squared, as opposed to -9 squared. The calculator sees those as two different things. So if you typed it in the calculator as -9 squared, no parentheses, you probably got it wrong. Because the calculator is not good at it. You have to put the parentheses around there because -9 times -9 is actually a positive 81, not negative. And then we have -4 times -4 times 5. So -4 times -4 times 4, or sorry, -4 times -4 times 5. There we go. I'm good at reading things. We actually get a positive 80. So we should have had 161. And you can just straight up type the whole statement in. If you put it in with the parentheses in, you can put your -9 in parentheses squared. -4 times -4 times 5. And it'll spit out 161 exactly as it is. So you can type it in the calculator exactly as it is right here. And it'll spit out the right answer. As long as you include those parentheses. You've got to include the parentheses. All right, then the bottom one is using what we talked about yesterday on our call. Oh, snap. Which most of you guys showed up for, which is fantastic. Thank you guys for doing that, participating. So, using our X frame to do this, and you can use the box, you can factor by grouping, or in any other number of methods that we have. My A up front is a 1. My C is a 121, so my A times C is 121. And we need a pair of numbers that's going to add up to our B, which is -22. So I need a pair of numbers that multiplies to make 121 and adds to make 22. Yeah, -11, -11. So when we factor this, and if you put it through the box, that works. If you factor it by grouping, that will also work. That is an unbalanced box. There we go. If you use the box, that's when we put our X squared here and our 121 here. And that -11 gets this middle variable, X. You do not have to do it in the box. You can also come and use it as an equation where we have our X squared minus 11X minus 11X plus 121. That also works. You can do it either way. No matter which way we do it, what factors are we getting? X minus 11 and X minus 11. So our factored form, we can write it as X minus 11 times X minus 11. Or since those two things are exactly the same, what else could we write that as? Perfection. Because I could 100% write this as x minus 11 squared. But I would 100% take both. Totally fine. Like, both would be absolutely valid. There's going to be times when noticing that it's a perfect square will help us when it comes to our solving when we get there later on. But for now, totally happy with either one of them entirely. Okay, questions on either one of those ones? Because our factoring is going to come up again today. Because we're going to use all that factoring we did yesterday, but then we're going to start solving. So we're not going to need to graph it to find our solutions, our roots, our intercepts. We're going to do these algebraically now. Hello, I feel like I skipped a slide. Oh no, I didn't. It's just in a weird order. There we go. There we go. Actually, no. I'm switching it back. This one first. Boop. Sorry. I'm changing my mind on things. I switched the order and then I decided to switch it back and like, it was just the whole thing. My brain's not braining this morning. Well, I'm trying not to do too much thinking. All right, so when we are solving by factoring, we always need it to be set equal to 0. So before we can try and factor stuff, we have to set it equal to 0. Then we need to check for a greatest common factor, a GCF, something that's shared between all three pieces. And then we're going to do our factoring, however we choose to. I will most of the times do box or factoring by grouping because these are the two most common that I see that get used. But if you have another method, there's lots of methods. There's just too many things for me to show all of them, and then it gets very redundant. Okay, so we have to have it set equal to 0. To solve it, we have to have it set equal to 0. That is super important. And we have to check for a GCF every single time. Once we get it factored, to get our solutions, I'm going to write it in down here. To get the solutions, the roots, the zeros, we're going to set each factor. So each of those parenthesed pieces, not that many O's, there we go, factor, equal to 0, and solve. So to get our roots, our solutions, our zeros, our x-intercepts, we're going to factor it, and then each of those factors is going to give us a solution. So each of those factors, like the x minus 11, each one of those will give us a solution. So I'm going to give us some quadratics. I've got, let's see, 1, 2, 3, I think I've got 4 for us today. For us to solve. We're going to get all the way down to roots or solutions, x equals, x-intercepts, zeros, those guys. Just give us a second. I still see some people writing. Whatever. We've got to set them equal to 0, check for a GCF, factor it, and then every factor that has an x in it, we're going to set equal to 0. Okay, I'm going to change it in 3, 2, 1. Boop. All right, so here's our first one. So the first thing we need to do is make it equal 0. I want it to equal 0. Ideally, we'd also like to have our x squared be positive, just because factoring with a minus x squared is super gross. So I don't necessarily want to move my x squared. It is already positive. So what could I do to make this equal 0 if I really don't want to move this guy? Minus x. So we're going to minus x from this side, which means I minus x from this side.
Would that make it negative 3x.
That would make it negative 3x. So what we have here is way too skinny. There we go. So we're going to have our 12x squared minus 3x equals 0. So we subtract that x from both sides. Is there anything that we can factor out of these terms? Is there a greatest common factor?
3.
3. Anything else? I can't take a 4 out of 3. But I can take an x out of both pieces. I can divide each of these by 3x. If I divide the 12x squared by 3x, what do I get that's left over?
4.
And
4x.
x. If I divide the 3x by 3x, what do I get left over?
Nothing.
Not 0. 1.
Negative 1.
So when we're looking at GCFs, what we're really doing is kind of baby fractions. So we had our 12x squared divided by 3x. That gives us 4x. And our 3x divided by 3x, that's where we get the 1. And it's just that this sign stayed the same. So don't put 0 in here. We are very rarely going to have zeros inside quadratics. So this still equals 0. Does everyone see how the factoring bit works there? Because that's factored form now. This was just had a GCF. I don't have any x squareds left, so I don't need to look at an x or a box. What we do need to do is we need to find our solutions. So this thing, this product, my 3x times 4x minus 1, is going to equal 0 when either this piece equals 0, so we're going to set our 3x equal to 0, or when this chunk equals 0. If that chunk equals 0 and we multiply those together, it's going to be 0. So we're going to take our 4x minus 1 and set it equal to 0. This is when we start doing our solving. This is finding our solutions. This was the factoring steps. So that's what we did yesterday. The bottom part is the new part for today, finding our solutions. So we set them equal to 0, and then we're going to solve it. We want to get to an x equals. So on my left one, on my blue one here, what do I do to get this x by itself? Divide by 3. If I divide both sides by 3, what do we get? X equals 0. So that's one of my solutions. I have a solution at 0. How about for my purple one? What are we going to do? Add 1 to both sides. That's going to give me 4x equals 1.
X equals 1/4.
Yeah, divide by 4 on both sides, and we get that x equals 1/4. And now is when we're going to start being able to find solutions for those. Well, it's somewhere between 0 and 1. Well, it's somewhere between 2 and 3. We're going to be able to get more specific, because this one is going to be between 0 and 1. It's just 1/4. So those are our solutions. These are our x-intercepts. There are roots. There are solutions. There are zeros. So we solved it, and we got x equals 0 and x equals 1/4. Okay. Questions on? You don't have, not on this one. We don't have to. You can if you want to. Like if you're not super confident, go ahead and substitute them back in. 100%, that should work. But we don't need to. But if we're not confident in our factoring or in our solving, that's an excellent way to double check it and see if you did it right. But we're not going to wind up with any extraneous solutions on these. All right, let's do another one. I've got x squared minus 6x minus 9 equals 18.
45. I know. I asked. He gave me the two answers.
You good? You good, Alex? All right. So our first step, we have to get it to equal what? I was like, it currently equals 18. What do we need it to do? Equal?
0.
We need it to equal 0. That is super important. Super duper 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 important. So very, very, very first step is to minus 18. From both sides. Has to equal 0 first. X squared minus 6x minus 9 minus 18 gives me minus 27 equals 0. So we've got it equal 0. Go team. Now we need to factor this.
3.
I need more information than 3.
Divide by 3.
Ooh, do I have a GCF of 3?
No.
Why not?
There's not a number in front of x squared.
Oh, okay.
Yeah, it's got to come out of everybody. So I do not have a greatest common factor. Most of the time, if I have an x squared, there's not going to be a GCF if there's no number in front of it. Most of the time. I'm not going to guarantee it, but most of the time. So, go ahead.
If there's no GCF, can we skip that step?
Yep.
Solve?
Just head straight into it. Yes, sir. Yeah, give me a second. So, we're ready to factor it. So, let's find our pair of numbers that helps us. Our a times c. My a is 1. My c is negative 27. So, we're at negative 27. And we need it to add to b. So, we need a pair of numbers that multiplies to make negative 27 and adds to make negative 6. What set of numbers will multiply to make negative 27 and add to make 6? Or negative 6, excuse me.
Negative 9, positive 3.
Negative 9 and positive 3. When in doubt, make a list of your factors of things that multiply to make 27. 1 and 27. Doesn't divide by 2. 3 and 9. And that's kind of it. So it's a matter of practice and being super careful and super intentional. So we have our minus 9 and our positive 3. That's our set of numbers. That is how that middle term splits into two different pieces. It's uncombining the like terms from when we multiply them together. So you can now put it through our factoring. Either put it through your box, put it through our factoring by grouping.
I thought that was
Well, we need to get it into factored form. The x is super helpful for that.
Nothing changed in the equation. We just found out. I don't know.
We're looking for these guys on the outside. These are the pieces we want. No, it's okay. The questions are important. That's what we want. So our x squared goes in the top left. Our minus 27 in the bottom right. Those two numbers we picked get the middle term. So I'm going to have a 3x and a minus 9x. So what factors do we get when we pull out columns and rows?
Is there a way we can do this without the boxes and the X?
Correct. You do. That's that would be like the factoring by grouping. You can do that one. Absolutely. You do not have to use the box. And I'll do the next one with the grouping. Yeah. So what do we have what are we going to get as our factors here? What is shared between x squared and minus 9? X. What is shared between 3x and minus 27? 3. What is shared between x squared and 3x? X. What is shared between minus 9x and minus 27? Negative 9. So we got our factored form is these outside guys over here. Oop. That's okay. So we've got our x plus 3 and our x minus 9 equals 0.
Set both of them to 0.
Set both of them equal to 0 to find our solutions, our roots. So we're going to do an x plus 3 equals 0. And we're going to do when x minus 9 equals 0. So this is putting it into our factored form. So this is standard form or general form. This is our factored form. These are how we find our solutions or our zeros. So for my left one here, my green one, my x plus 3 equals 0. What do I get when we solve for x? X equals, what do we get on this one? Negative 3. Subtract 3 from both sides. On the right one, my x minus 9 equals 0. What do we get as our solution? Positive 9. Add 9 to both sides. So our two solutions are negative 3 and positive 9. And like I said yesterday, and I kind of mentioned just a second ago, there are so many different ways of factoring. So many different ways of factoring. I know like 4 or 5 of them pretty well. There are more than that. So if you have a different way of factoring that is not one that I do up here, but you are comfortable with, that is okay. If you absolutely cannot stand any of the things that I do as techniques for factoring, go check YouTube. There are gazillions of techniques. And something will work for your brain and the way that your brain likes to flow through stuff. My brain works really well with factoring by grouping, but I can do the box pretty well because I know a lot of people here are very comfortable with the box. But there are lots of different techniques for factoring, and I don't care how you factor, just that you factor, and you've got to show me work so I can figure out what you did to get there. Okay, questions on this one? All right. Next one.
The greatest common factors 4.
I was going to say, but let's set it equal to 0 first. So let's subtract our 4, because you're going to be right, Abigail, but it's going to be easier if we have it set equal to 0 first. So let's subtract 4 from both sides to get this thing equal to 0. That's our first job, is to get it to equal 0. So we're going to have our 4x squared, our plus 12x minus 40 equals 0. And I've already heard some of us notice it. What do we notice here? We have a greatest common factor. What's our greatest common factor? 4. So we're going to take that 4 out as a greatest common factor. It's just going to sit up front. I like to think of it kind of like an obnoxious little kindergarten line leader going, I'm in the front, I'm in the front. And then we just ignore him. He just sits out there. So if I divide each of those terms by 4, 4x squared divided by 4 gives me just x squared. Yep, 12x divided by 4 is going to give me 3x. And 40 divided by 4 gives us 10 equals 0. If you are not super confident in that, re-multiply that through. It should give you exactly what we had. What are we doing? Let's do this and keep our face out of other people's business. Up here is where we're focused. Thank y'all. Okay, felt incredibly sarcastic. I felt very much like, from the outside. It had that energy. So, let's not. Let's just not. All right. So now we've got this GCF of 4 taken out. We need to take that GCF out. I promise if you do not take a GCF out, your factors will be wrong. It makes a difference. So now what we're going to do is we're going to try and factor this guy in here. The 4 is irrelevant now. He sits out in front. We ignore him. We're going to factor that piece. And I'm going to do this one with our factoring by grouping, just so we can see both of them. We still start the same way. We're going to pick our a times c. Now my a in front of the x squared, I've got a 1 and my minus 10. So we're looking for a pair of numbers that's going to multiply to make negative 10 and adds to be a positive 3. What set of numbers will multiply to make negative 10 and add to make a positive 3?
5 and negative 2.
5 and negative 2.
Does it matter which side?
Does not, even a little bit. So again, if you like the box all the way, more power to you, rock on. I'm going to do this one factoring by grouping style. So our 4 is still going to hang out in front. He's just chilling. And then in here, I'm going to have my x squared plus 5x minus 3x. Oh, sorry, minus 2x. Minus 10. I'm like, that was not right. Changing colors. There we go. Minus 10. Equals 0. And again, if you are someone who much prefers the box or is more comfortable with the box, do the box. Do the box.
I did the box.
Yep.
So do I just...
Put it in factor form. You will wind up, like, we'll wind up there in like a step and a half.
So like have the 4 in front?
The 4 is still going to be in front, yes.
Yep. And then do I put it all in parentheses or put them in their separate?
They're two separate, you can do it in their two separate parentheses. So I'm breaking these in pairs. Whenever we have a minus sign in the middle of a factoring by grouping, I always tuck it into the second one. It just makes it easier to make sure we pull the right sign. So what you do with our factoring by grouping is we're pulling out a GCF from each of these terms. So it does wind up with an extra line of writing this way, where we have our, changing colors, x as a GCF here, giving us x plus 5. And we pull out a greatest common factor, you don't got to do it this way then, of minus 2, which will then give us x plus 5. Do the box way. If this is confusing to you and you have never seen this before, don't do this way. This is just the second most common way I've seen a factoring done in a school. Like, there are other ways. If you don't get what is happening here, do it through the box. You'll get the exact same step in this next bit, where I take out my x plus 5 as a GCF of the inside. And my leftover bit, I have an x minus 2. We have that greatest common factor of 4 out front, and it still equals 0. If you do the box, you should still have wound up with x plus 5 and x minus 2.
Why you can't just assume when you have your greatest common factors to just do x in front of it and equal it to 0 and skip all those other steps?
You mean like from here, just hop straight down to here?
Yeah, because when you do your little x thing, it gives you both. And
I was going to say, that only works when you don't have an a value.
oh, okay.
So if you have an a value, you have to do a box or a something.
Okay.
But yes, and as we go through this, we'll start to notice shortcuts like that. Absolutely, excellent catch on that, Alex. Is that our pieces in here, our positive 5 is exactly what we had here. Our negative 2 is exactly what happened here. That only works when our a is 1. That only works when a is 1. So we can't take that as like a universal shortcut. But that does work when our a is 1. And if you've noticed that pattern, great. Otherwise, run it through some sort of factoring. So now we need to find our solutions, our roots, our zeros. So I'm going to take every factor that has an x in it and set that equal to 0. So I don't need to do anything with my 4 out front. There's no x in there. What we do need to do is look at our x plus 5 equals 0 and find that solution. And we're going to look at our x minus 2 equals 0 and find that solution. So where are we going to have solutions? Roots, x-intercepts.
Oh, good.
X equals negative 5.
Mm-hmm.
And x equals 2.
Why are y'all so giggly? Just we got giggles galore. Bro, for real. Oh my god. Oh my god, be so for real.
So what are we gonna do with these x's? Like, we're just.
So those would be
Like,
our
where's
x.
the point?
Those are finding our x-intercepts. So if I was to come and graph this, that would tell me
How do we
that-
find our y?
so these are x-intercepts. So -5, that's this guy right here, and our +2. I'd have a point right there. I could then go through and find my axis of symmetry. I could find my vertex. I've got a y-intercept here on this line at -40. So it's going to come way down here. So, like, we're getting information all about this parabola. And it does come into play in things like story problems when we're looking for x-intercepts, when things hit the ground, things like that. Was that your question?
Yeah, I was asking how this is based on real world.
In real world, this would be, think about catapults. On the ground, launch. Splat, pumpkin catapult. Where it is, where it landed, those would be our intercepts. Where it hits the ground. Or the book is going to give us one that's kind of extra. We are going to do one that's a real world story problem. It's the last one for today. And I promise the equation is gross, but I will help us through it. So this would be a business style equation.
Yeah.
They've given us the equation for their profit, which they have calculated. And we are asked to find, based off of that, when they make no profit. Because this is the equation for profit. So we want to know when there is zero profit. They're not losing money. It's not negative. But they're also not making money. There's no profit. So we're looking at this equation. That is not my stylus. Looking at this equation here. And they want us to find out when the profit is 0. So when it equals 0 instead of the p of x. Minus 16x squared plus 1712x, ew, minus 44,640, ewer. That's worse. Super gross. But they want us to find those zeros, those roots, those x-intercepts. That's when they make no profit. So as long as they keep their prices between there, they're going to turn a profit. So what we're going to do is we're going to try and factor this. And I know Cooper already noticed it, but it does have a GCF. All of these numbers are divisible by 16. So what we're actually going to do, because also when we're factoring, we don't like to have minuses on our x squareds, is I'm actually going to factor out a GCF of negative 16.
Why are there so many numbers?
Big numbers. So I want to factor out a GCF of negative 16 because I really don't want to have to deal with minus x squared and factoring. Ew, gross. So if I take our minus 16x squared and divide it by minus 16, we get x squared. We like that better.
Okay.
I'm going to take 1712 and divide it by negative 16. And that's going to give us negative 107x. Sounds like a radio station. And then we're going to have our minus 44,640. Yeah. And divide that by negative 16. And we're going to get positive.
2,790.
Yes.
Ooh.
Ew.
Too many numbers.
So what we're looking for when we're trying to figure out these zeros is we're trying to figure out which pair of numbers is going to multiply to make 2,790. And add to negative 107. So if we're multiplying to be a positive number and adding to be a negative, that means they're both going to be negative. So then let's look at the values we have. And since it's multiple choice, we can kind of use that as a shortcut. Is there a set of values in there that does multiply to be 2,790 and add to be 107.
Oh.
Instead of trying to go through the list of factors of 2,790, ew.
Okay.
Negative 107.
What two things?
It's
She said
45 and 62.
Yeah, I was gonna say, so when we're looking at it, I know they're gonna be negative, so it doesn't matter if they add to positive 107 or negative 107, like that's okay. But what we're looking for here is which set of these options, multiple choice, use the tools at our disposal, is gonna meet the criteria here. And it's actually gonna be these guys right here. So minus 45 and minus 62. We can use that set of options for that since we have a 1x squared. So it lets us try that. Yes, sir. Mm-hmm.
So how do you, how do you know what goes in which spot?
Top left box always catches your ax squared. So our 1x squared always goes here. Our c is always going to go bottom right. So I'm just going to erase the 1 because we don't need the 1. And the c, that 2,790, always goes bottom right. As far as the other two spots, genuinely doesn't matter. If I put the negative 62 on the left or if I put the negative 62 on the right. It genuinely does not matter.
So you're always gonna have an x squared.
Always going to have your x squared top left. Always going to have your constant, your thing with no x's bottom right. Every time.
And then the top right, bottom left.
It does not matter which one it is. They can switch. So I could put my minus 45x. It gets that single term. My minus 62x. We could pull our factors. It's going to be that same exact thing that Alex noticed earlier where we have our x minus 45 and our x minus 62. And our factored form is exactly that GCF, our minus 16. I'm going to write it under here. X minus 45.
I don't know why, but I just started writing 42 instead of 45.
You mix together the 45 and the 62. You're just trying to make it efficient. So we've got it in our factor form, but we've also got our answer. We found it using the tools we had. You don't have to finish out the factored form. Because we figured it out. It's between $45 and $62. As long as they price their clothing between those two, the new dress should be between $45 and $62.
That's expensive.
Shouldn't we still write equals 0?
Equals 0. Yes, I'm sure no space. Boop. So that's our factored form right there. Okay, it's unpleasant. And honestly, I won't give you ones that big. They're gross. We are going to keep working with solving by factoring tomorrow. But I'm going to give you guys,
No.
yes, more solving stuff. Huzzah. 3.4 is not due till Friday. So it is solving.
Fridays are first. It's the opening day for Spy Class.
I'll be there for the closing that day. Alright, here's 3.4. It's not due till Friday. We're gonna work more with these tomorrow, but it's not super much different tomorrow.
I forgot my pencil at my ASM station yesterday.
Mm-hmm.
And I don't have time to go get it until 7th period because my 7th period is legit in the beginning. Yeah, I brought
I have plenty.
And I don't know where my extra